before moving on further with hypothesis testing, I want to get a lot of practice with actually writing out hypotheses. This is going to be essentially, as soon as we get to the point where we're doing like homework problems or like actually trying to get these things done, the first thing we're going to do is actually write out our hypotheses. So we're going to kind of skip forward in the hypothesis testing framework in terms of like deciding our statistical question, gathering the data. We're kind of going to assume that we set up these hypotheses and then gather data. We can't do all that in the span of a 5-minute homework problem, right? So this is going to be really the first step in a homework problem. And if we do it wrong, everything's going to be wrong after that. So this is going to be of prime importance to make sure we're getting these things right, which is why I'm going to go through a lot of examples now and then have you get some practice with it before moving forward with the other ideas behind a hypothesis test. So here's how we should start with just writing out hypotheses. First, we need to figure out which measure we're using in our test. Now, luckily, this is a little bit easier for us in an intro class because we're really only looking at 3 things that are fundamentally just different. So the first thing we should be thinking about is what kind of variable we have. Because if the thing we're looking at is categorical, right, like whether we have an iPhone or not, the only one of these 3 measures that makes any sense is a proportion. I can't find the mean of having an iPhone or not having an iPhone. That doesn't even make sense. Same thing with the standard deviation. So if I have categorical data, if I'm working with categorical variables, a proportion is what I'm looking for without question. And then the other 2 are fundamentally measuring something different. A mean is looking at kind of typical or usual or central values for something, and a standard deviation is measuring how spread apart those values are. These are completely different concepts. The mean is where we might expect things to lie, and a standard deviation is how far apart our data is going to be from each other. So these will be, I feel like that we've narrowed these things down so much to these 3 that this should be, after we get some practice, fairly clear on which one we should be doing. So after I figure that out, I need to compare that value to some number. I'm going to need to give this to you essentially in the setup to the problem. So it's going to be some baseline or standardized value, or it's going to be something we figure out based off of the context of the problem, which again, we're just going to get lots and lots of practice with as we move forward. And last, I need to figure out what symbols I should be using. So remember, our null and alternative hypotheses will have a parameter, mean, standard deviation, or proportion, a number we're comparing that to, at least at first, and then the null hypothesis always has an equal sign, so it'll be like the mean equals 5 or something like that. And then the alternative will have a less than, a greater than, or it doesn't equals. Those are the only 3 options. So the null is essentially already set. We know it's got an equal sign in it. And the alternative, we just need to figure out if it's less than, more than, or doesn't equal. And that, again, we're just going to get practice with. So as you'll see moving forward in the course, we're going to be using software to really conduct this hypothesis test for us, do all the calculations and just kind of pop out the stuff. The issue is going to be setting this up and understanding what's actually going on with this. And the trick with that is really going to be working with word problems. And I know that people always hate story problems in their math classes the most, but story problems were the only things that were actually applicable to real life ever. X plus 5 equals 7 is completely useless in the real world. Story problems are the only times we can actually do something productive, and I need for this class to be productive if I'm going to ditch all the calculations, right? At least by the time you get out of this course, you'll be able to do something worthwhile with this information. So I know at first you're going to hate that we're doing story problems constantly, and that's basically all we're going to do for the entire rest of the course is story problem after story problem, but that'll ensure that we're able to apply all this stuff to practical and useful situations. Okay, so let me just start off with a couple of basic ones, and then I'll put the rest of them in a different video. So, can we support the claim that high school GPAs at Casper College are different from 3.48, the average at UW? So we mean like the transfer, like the GPA, like not the GPA at Casper College, but the GPA of students that are here from when they were in high school. So incoming freshmen at UW have a GPA, a mean GPA of 3.48, and we want to see if it's different from that. So first off, the two main ideas I have here are that the mean either is 3.48 or it's different from it. Right? Those are my two claims really. So I've been given the claim, is Casper College mean different from 3.48? And the competing claim would be that it's not different, in other words, the same, right? And we're told, can we support the claim that it's different? Well, the only place I can support claims is in the alternative. Remember, I can reject claims in the null, in other words, say that they're wrong, but I can't ever say the null hypothesis is true. So if I want to show that something is true, and that's what support means, then it's got to be in the alternative. So I will always have, of course, a null and alternative hypothesis. It directly said we're looking at a mean, so I know what symbol I should be using here. It gives us the baseline value that I want to be looking at, 3.48, I think. Yes, 3.48. And we're asked, can we support the claim that it's different from that? Well, I said I can only support claims when they're in the alternative. And different, it could be less, it could be more, right? Either way would mean different. So that symbol that we want to use is doesn't equal. And remember, this one always is equal. So these would be my hypotheses for that situation. Let's look at one more real quick. Test the claim that at least 37% of Casper College students graduate with an associate's degree within 2 years. All right. So, two things right off the bat. One, I see a percent symbol here. I don't see any reference to means or standard deviations. And as I look at this, and think about it, what kind of data would I actually have here? Right? If I had a data set and I was looking at this, the data that I would have would be like, yes, they graduated within 2 years, or no, they didn't. That's categorical. And the only thing that makes sense there is proportions. And indeed, I'm given some baseline proportion of 37%. And specifically that this proportion is at least 37%. So let me write that down real quick. So the proportion, pi, is at least 37%. And I'm just going to write that as a decimal because moving forward, software is going to want us to just write it as a decimal. So I'm just kind of getting us ready for that. All right. Now, it says test the claim. And I'll admit, personally speaking, at least, test the claim is not immediately obvious what that means. Does that mean, check if it's true or check if it's false or what here? And just because constantly in textbooks and therefore more advanced textbooks and therefore further coursework is going to use this phrasing, what that means is test if it's true. All right, so I hate that this has to be just some phrasing that we just know means that. But when I say test the claim, and again in plain English, right, you would, if this were to happen in real life, you would just ask the person, wait, what do you mean? Are you trying to show that that's true or are you trying to show that that's false? Test the claim means put that claim in the alternative hypothesis. In other words, can we support that claim? I'll buy that, and that's fine. It's in every textbook I can find, so I'll just go ahead and go with that. So that's what that means. So when I said test the claim that the proportion is at least 37%, that means that needs to be my alternative hypothesis. Now there's a little issue here. I'm not allowed to use this symbol. I can use a greater than symbol, a less than symbol, or a doesn't equal. Well, if you remember, what we're actually going to do here, right, like what I did with the lengths of pregnancy example, was to find a probability and then see how unusual my data was using that probability. Well, if this thing, proportions are going to be basically a continuous variable here, there's truly no difference between this and this. It's the same thing. There's no difference at all. So we just need to adjust things, right, from what we're given, because at least is technically speaking this, right? That's what at least means directly. But I can just get rid of that, and I'm good. All right? So remember, the null hypothesis will always have the same symbol, the same number, but it will always have an equal sign. So once I have the alternative written out, the null kind of just writes itself. All right, so in the next video, I'm going to give a lot more examples, but that's good enough for just a rough idea of what's going on.